Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nur Zaifi bin Abdul Halim. For our Group 9 Numerical project, I will introduce the introduction for our group project. So, problem-solving approaches include experimentation, simulation, and mathematical model, analytical or numerical. Experiments provide valuable data but can be costly. Simulation, often using computer models, help analyze system behavior and predict future outcome. Numerical methods, essential in the computer age, approximate solution for complex problems in science and engineering. Numerical analysis focuses on algorithm for solving mathematical problems, including linear equation system, which are widely used across various scientific fields.
Assalamualaikum, my name is Amir and I will present a literature review. So for the thermodynamic process is represent how attribute of a system deviate from their initial values, leading to change in the system state. So there are six main type of process. So first is adiabatic, where no heat is transferred. Second is isothermal, where temperature remain constant. Isobaric, with no change in pressure. Isochoric, with constant volume. Isentropic, where entropy remain unchanged. And for the last is isenthalpic, where enthalpy does not vary. So interpolation is a numerical method used to estimate value by expressing data through suitable polynomial. Newton divided difference method is widely used in this context. It incorporates linear and quadratic interpolation technique to calculate dependent variable accurately. The split different polynomial approach is based on the Newton form, which use variable that define interpolation sites to construct polynomial efficiently. So the study applies interpolation method using tabulate data from thermodynamic process. This numerical technique are critical in civil engineering application, ensuring precise evaluation and aiding in the analysis of system behavior.
Hello, Assalamualaikum. My name is Muhammad Amirul Shazwan. My metric number is BF25203 Okay, I will continue our presentation about a methodology. Okay, for the first one is trapezoidal rule. The trapezoidal rule, commonly referred to as the trapezoidal rule or trapezium rule, is a numerical analysis method for approximating the definite integral. The trapezoidal rule is an integration rule that divides a curve into smaller trapezoidal to estimate the area under a curve. The summation of all the areas of the small trapezoid will give the area under the curve. When the underlying function is moved, the trapezoidal rule does not provide an exact number as a Simpson rule does. This is caused by the fact that Simpson rule employ quadratic approximation rather than linear approximation. Both Simpson rule 6 and the trapezoidal rule produce an approximate number for the integral, but Simpson rule produce an even more accurate approximation value. The trapezoidal rule formula is given below. Okay, this is the formula for the trapezoidal rule. Next. Okay, I will continue about the Simpson 1/3 rule. Okay, for the Simpson 1/3 rule, require two minimum segments, whereas the trapezoidal rule only one. We generate an area A1 with n equal to 2 segment under Simpson 1/3 rule using Newton forward difference up to second order, provided by fundamental formula of this is the formula for the first one, and for the second one is for beta currency, the interval A B is divided into n equal to 2m, which is m and n are integer. Subinterval x1 I of the width HBEN such that the integral is approximated by composite Simpson 1/3 rule as the formula given below. Okay, for the last one is Simpson 3/8 rule. Simpson 3/8 rule, as called Simpson's second rule, is another method for numerical integration proposed by Thomas Simpson. It is based upon a cubic interpolation rather than a quadratic interpolation. Simpson 3/8 rule is as follows. The integral is more accurately approximated by the composite Simpson 3/8 rule. This formula is for Simpson 3/8 rule.
Hi, my name is Ahmad Bashir bin Rosili, and I will be continuing the presentation for the result or data analysis, which is the calculations. As you can see at the slides, we are showing the trapezoidal methods, which is we will be using the trapezoidal rule, which is this calculation use the trapezoidal rule to approximate the integral of function, and I will show you the step by step for the calculations. For the first step is we need to understand the trapezoidal rule, which is we will be using the rule which is the function which is integral BAF multiplied by x dx and equal to h/2 and f0 plus 2f1 plus 2f2 and plus 2fn minus 1 plus fn, where h the step size between the consecutive values of x, and for the fo, f1 until fn, which is the function values at each point. The second step is we need to extract the information from the table, which is will be given the v represent for the x values and p represent the fx values at corresponding v values. And for the function values, fx are 300, 287, 276, 258, 251, 239, and 190. For the third step, which is we need to determine the step size, which is the S value. These are not equally spaced. An A weight or average or explicit interval calculation is used, which is here H effective equal to total interval length divided by number of subintervals, which is we will get 10 minus 0.5, and divided by 6, we will get 1.75. And for the fourth step, which is the substitute into the trapezoidal rule, and the integral approximation becomes integral 0.5 and 10 fx dx equal to h over 2 multiply f0 plus 2f1 plus 2f2 plus 2f3 and plus 2f4 and plus 2f5 and f6. After we substitute the values, we will get 2519 kj. The result of the 2519 kj is the approximate integral of fx over the range 0.5 less or equal v less or equal 10 calculated using the trapezoidal rule. This method approximates the area under the curve fx by dividing it into trapezoids and summing their areas. Is a straightforward numerical technique for integration. Next, for these calculations, we will be using the Simpson's 1 over 3 rules, which is this table and calculation appear to be related to numerical integration, specifically which is the Simpson's rule. The first step is we need to understand the structure of the table, which is the table will provides values for I, which is the index of data points, and xi, the x coordinate values at which the function fx is evaluated. And for the f multiplied by si, functions values at si, and f odd functions value are corresponding to odd index, which is for the odd numbers, which is 1, 3, 5, and so on. And for the f even, which is the function values corresponding to even index, which is for the even number 2, 4, 6, 8, and more. The sum rule is used to compute totals for FO, Fn, F odd, and F even. And for the second step, which is for the Simpson's rule, is given by I equal to H over 3 and multiplied by Fxo plus Fsn plus 4, and the odd index, which is Fsi plus 2 even index, and Fsi, where the H step size between consecutive Si, which is the Xn minus Xo over n. And for the FSO function value at the first point, and FSN function value at the last point. And for the odd index, sum of function values at odd index, and the even index, sum of function value at even index. Abstract data for the third step, which is the abstract data from the table, which is FSO equals to 300, which is, as you can see in the table, which is the first row, and the FSN equal to 190, which is the last row. And for the odd, FSI equal to 784, sum of values in F odd column, and even FSI equal to 527, sum of values in F even column. For the fourth step, which is substitute into the formula, the integration formula becomes I over H over 3, which is multiply FO plus Fn, and 4 odd plus 2 even. From the table, H step size is not directly shown, but it can be calculated as H as n minus SO and divide by n, which is the 10 minus 0.5 equal to, but divide by 10 minus 0.5 divided by 6 equal to 1.5833. And we need to substitute the values, which is the I equal to I 1.5833 divided by 3 and multiply by 300 plus 190 and plus 4 multiplied by 784 and plus 2 multiplied by 527. And then we need to perform the calculation, which is to compute the sums inside the brackets. And after that, we need to multiply by H over 3, which is 1.5833 divided by 3 and multiply by 4,680, which is we will get 2,469.95 kg. The final result, 2,499.95 kg, represent the approximate integral of the function, which is the fx over the range of x values using the Simpson's rule. Next, which is for this one, is we will be using the Simpson 3 over 8 rules, which is for the numerical integration, and the grouping and naming in the table are slightly different. This 3 over 8 rules is slightly different from for the 1 over 3 rules, which is for the first step we need to understand the table structure, and equal to I is equal to index of data points, and for the SI is the x coordinate values where fs is evaluated, and fs of which is the function values at each SI, and f0 fn values at the first FO equal to FSO, and last fn equal to FSN data points. F in segment, sum of function values for intermediate odd index, and F in segment, sum of function values for intermediate even index. The sum row provides total for F0 and Fn, which is F in segment and Fn segment. Second step, which is we will be using the formula for Simpson rules, which is I equal to H over 3 multiplied by FSO plus F Sn and plus 4 for the odd indice and FSI plus 2 even indice FSI. And next, for the third step, which is the substitute into the formula, which is Simpson's rule becomes 1 equal to 3 multiplied by 1.5833 divided by 8 and multiplied by 490 plus 3 multiplied by 1053 and plus 2 multiplied by 258. H is equal to 1.5833 calculated as Sn minus SO divided by n, and we will get 1.5833. And 3 multiplied by H over 8, this factor arise because it appears this integration use Simpson 3 over 8 rule, which is the version of Simpson's rule. And then we need perform after the calculations have been performed, the calculated the sum inside the brackets 490 plus 3 multiplied by 1053 plus 2 multiplied by 258, we will get 4165. And then after that we need to multiply by 3h over 8, we will get the 2472.92 kg. The result 2472.92 kg is the approximate integral of fx over the given range of s values calculated using Simpson's 3 over 8 rule. This method is particularly accurate for cases where the data points are not equally spaced or when higher order accuracy is desired.
So this is a discussion about the method. So in this analysis, we evaluate the accuracy of the trapezoidal method, Simpson 1 over 3 rule, and Simpson 3 over 8 rule. Based on the calculated result, it was observed that the result vary depending on the method and parameters applied. So the value we obtained 9,519 kJ using the trapezoidal method and 2,469.95 kJ with Simpson 1 over 3 rule and 2,472.92 kJ with Simpson 3 over 8 rule. This result indicate that Simpson method provide value closer to the actual result, especially for function with an increasing gradient. Although the precise definition of error term is beyond the scope of this course, it is essential to note that the combination of method in Simpson rule generally eliminate that error term for function up to the cubic degree. This makes Simpson rule more accurate for more complex function. In summary, Simpson rule offer an advantage in terms of accuracy for complex function. The selection of the method depends on the function nature and the requirement of the analysis.
So the conclusion in our project is firstly accurate of method. The 1 over 3 Simpson rules and 3 over 8 Simpson rules can be identified as the most accurate numerical method for solving this problem. The importance of numerical technique, which is this method are essential in civil engineering and allow precise solution that cannot be solved by analytically. The efficient engineering numerical method can simplify the conclusion and enable the engineer to work more quickly and accurately in real-world application. The education integration, we can use numerical method into our education, develop to advanced problem-solving skills, which can be essential for tackling unknown variable engineering and others field. Lastly, the future benefits for our studying numerical method can be mastery and be prepared for student for our brighter futures and successful career, particularly in technical profession like us in civil engineering. Okay, that's all from us. Thank you.